Warm welcome. So now in today's class we will continue with the continue from the last class. Last class, like we were discussing probability distribution, so and then we have discussed the mean of an expected variable. We have discussed the mean of a random variable, that we also call it as the expected value. So and then today we will start after that, that is we will proceed from there, that is we will discuss now variance of a random variable, how to calculate the variance of a random variable. We have also seen, while calculating the mean of a random variable, we have also seen that how to calculate the mean of gx. What was gx? Remember last class we have discussed that. What was gx? Gx is a function of x. So how we have calculated the mean of gx? Mean of gx was same, instead of x we have just written it gx. So let me just take the board and then explain it. So how we have calculated the mean of gx? Mean of gx is summation of gx fx and summation over all the values of x. Right. So what is gx? Gx is a function of x, right? So now when we are interested in finding the variance of a random variable, what is variance? Basically when we calculate variance, how do we calculate variance? We calculate variance, what is represented v square, we calculate variance as summation of xi minus x bar whole square by n minus 1, right? This is the formula for variance. Now this cannot I write it this way? This is nothing but this is mean, isn't it? When I am dividing it n minus 1, I am just finding the mean of all these values. All the values what I have get, I just divide it, because total this much values I will get, and I have divided it by that. So this I can just write it as mean of xi minus x bar whole square. Okay. This now what is this xi? Xi means all the different variables that the random variable will take. So that means I can write it, instead of xi, I can write it as x, that is the different values that a random variable will take. Okay. And instead of x bar, see, we have already discussed, when we talk of mean of a random variable, either we use the term mu or we use the term mu e of x. So let me call it as use mu. So xi minus mu whole square. So that means when I am interested in finding the variance of a random variable, so that essentially I need to find expected value of x minus mu whole square. Now what is x minus mu whole square? It is nothing but a function of x. So what is, how do I find out expected value of x minus mu whole square? Just putting it in this formula. I'll just put it in this formula. Okay. So if I put it in this formula, what I get? What is my gx? Gx is x minus mu whole square fx. So what information I have? I have all the values of fx, what the values the random variable will take. I have all the values of fx, that is probability of fx. Then of course I can find out mu from the formula what we have learned, and then with this I can find out my variance. Now my variance is this, right? So that's what. Here we see, you see this is the variance. Variance is expected value of x minus mu whole square. If it is discrete, we use summation. If it is continuous, we use integration. Okay. So what is, see here, this here in the example I have given two distribution. So distribution here, mean is same for both the distribution. Mean is here also mean is 2, here also mean is 2. Here it's mean is 2, here the mean is 2. But the variation is different for both the cases. This is here the variation is very less, here the variation is quite more. It's more spread out, right? Variance means how spread out it is. It is more spread out, right? So it is an example. So what it is given? Let the random variable x represents the number of automobiles that are used for official business purpose on any given work day. Okay, number of automobiles that is used in any given work day. In any given work day, company may use 1 automobile, 2 or 3. What is the probability of using 1 is 0.3, probability of using 2 is 0.4, and probability of using 3 is 0.3. And again there is another company which may use in a particular day, it may use no automobile at all, that is 0 or 1, 2, 3 or 4, and the probability of all these values are given. For 0 is 0.2, and likewise it is given in this table. Now what we have to see is show that the variance of the probability distribution for company B is greater than for company A. We have to show that the variance for company B is probability distribution of company B is greater than for company A. That means what we have to find out? We have to find out the variance of company A, then we have to find out the variance of company B, and from that we will see that the variance of company B is greater. How we will do that? Now how to find out the variance? To find out the variance, first we need to find out the mean, right? Mean is nothing but, what is the formula for mean? Mean is summation of x fx. So what is the x value? X is 1 into 0.3, 2 into 0.4, 3 into 0.3. Fine. Now what is variance? Similarly, variance is x minus 2 whole square, that is variance is x minus mu whole square fx. So my mu is 2, x minus mu whole square, x minus 2 whole square fx. Okay. So what is this? X minus what value x will take? X will take 1, 2 and 3. Okay. So 1 minus 2 into probability of 3. So this is 2. Okay. So 2 minus 2 into probability of 2. There is a slight mistake in the slide, I am sorry for that. Okay. And then next is the, it will take the value 3. So this value is 3. So 3 minus 2 whole square into that probability, that is 0.3. So what we got, this will count out to be the 0. 2 minus 2 is 0, and this from this and this we will be getting 0.6. Similarly, we will find out the variance for company B as well. So once we find out the variance for company B, same way we found it is 1.6. So the variance A is 0.6, variance B is 1.6. So definitely company B's variance is higher. Okay. So now some basic laws to compute variance. Variance, that is, we can tell it as Vx. Vx is equals to V of x square minus mu square. V of A plus Bx is equals to B square V of x. V of x plus minus y means two random variable x minus y, which has two different distributions. So whether these two random variables we add it or sum it, the variance what we get is V of x plus V of y. This is a very important conclusion. You may need it in many other problems when we are trying to find out the variance of two different populations. Okay, and we are trying to variance of two different populations. If the even earlier it was V of x plus y or x minus y, always it will be, always the variance are added, variance are never subtracted. Okay. So now how to, we can also see how we can deduce this. Okay, I will be showing you one or two, rest you can do it by yourself, this in a similar manner. So okay, so first we will see the first one. What was the first one? First one is E of V of x. V of x, how I can write? V of x I can write as E of x minus mu whole square, right? So if I break it, how it is? X square minus twice x mu plus mu square, right? So using the rule for expected value we have seen. So this is E of x square, this is 2 of x mu, so this is 2 of mu into E of x, because mu is constant, so its expected value will be just mu only, and then mu square. What is mu square E of x? Mu square E of x is and this E of mu square will be simple mu square, that is a constant value. So what we got? E of x square minus E of x is what? E of x is mu, so we got 2 mu square plus mu square, so we got E of x square minus mu square, right? So this is the first reason. V of x is E of x square minus mu square. Okay. Similarly, second one, okay, second one also I will show you, but third one you please do it yourself. So V of A plus Bx is equals to V square Vx. How will you find this? Okay, so for this we need to find out V of A plus Bx, right? A of B plus. So what first we will see here, we already know what is E of A plus Bx. E of A plus Bx we already know, we have seen in our last lecture that it will be A plus B of Ex, right? So now when we are interested in finding out V of A plus Bx, what is this? This will be equals to E of what? x minus mu whole square, right, is equals to u of, this is, if I consider this as x, so a plus bx, this is x, minus mu, mu of means mu of this. What is mu of this? I have done it here, that is minus a minus b of e x, right, whole square. So what we got? This a get cancelled, b square remaining, right? What is there? What remains? So it will be x minus e of x is what? E of x I can write as mu, x minus mu whole square, right? So what is this? E of b square I can bring out. Let me cut this. So this is b square e of x minus mu whole square. Okay, what is x minus mu whole square? X minus mu whole square is nothing but v. So this I can write as b square v of x. Again I am repeating how I have done. So I am interested in finding out v of a plus bx. What is v of a plus bx? V of variance of x is x minus mu whole square, right? So my this is x, this is x. So x minus mu, mu means mu e of x. So my this is x, and this portion is my e of x. E of this I have seen it is this. So I have subtracted this, a get cancelled, what remains is b into x minus e of x. E of x is mu, x minus mu whole square. So b square I am bringing it outside. So I got b square e of x minus mu whole square. And now what is this? This is nothing but equals to v of x. So similarly you can find out, try and do the third one. Now there is an important theorem. Important theorem in the sense like, see, you understood what is a variance. Variance means how spread out my data is. Now this you see in this figure, and this figure, both the figure may have the same mu, same mean, but say this figure is more spread out, this second figure, this figure is more spread out than compared to this figure, this figure is more spread out. The spread out means its variance is more. And suppose I am interested in finding out what is the, in a random experiment for any particular event, I am interested in finding out what is the probability that my value will lie in this interval, some distance from mu. Similarly, I have considered the same distance from mu. What is the probability of a value lying in this interval? Okay. So in this case, the probability of lying in this case, my probability of lying in this interval will be high compared to this. My probability of lying in this interval will be high compared to this probability distribution. Why? This probability is nothing but, in case of continuous probability distribution, it is nothing but the area. If you consider as the area, this area is, because this whole area corresponds to 1, so definitely this area will be less compared to this area. So that means my probability of will be higher lying in this range. So Chebyshev theorem basically gives a very conservative estimate of that. So if I, in any random experiment for a particular event, the probability of lying within a particular distance from mu. Okay, what is the probability of getting a value within a particular distance from mu? That Chebyshev theorems gives that. So what is that? The probability that any random variable x will assume a value within k standard deviation of the mean. K standard deviation means 1 standard deviation. So suppose I have drawn a figure, suppose this is my figure, suppose this is mean, and suppose this is 1 standard deviation. This distance is standard deviation. Standard deviation is variance, root over of variance. This is my standard deviation. Okay. This is my standard deviation. So this is 1 standard deviation. Then 2 standard deviation may be this point. What is the probability of lying in this region, within this region? 3 standard deviation may be this point. What is the probability of lying within this region? So, what does Chebyshev theorem says? The probability that any random variable x will assume a value within k standard deviation is at least 1 minus 1 by k square. But here this is applicable when k is greater than 1. It is not applicable for k equals to 1. Okay. So, above theorem due to Chebyshev gives a conservative estimate of the probability that a random variable assumes a value within k standard deviation of its mean for any real number k. Okay, it's clear. Essentially, what does Chebyshev theorem tells? Chebyshev theorem tells what is my probability of getting a value in a particular range. This range is specifying by the standard deviation. What is the probability that I will run in a random experiment and I will be getting a value? How much standard deviation from the mean? Mean is the middle portion, right? From this mean, how much standard deviation? So if it is 1 standard deviation, means maybe this. 1 standard deviation may be this mean, this may be 1 standard deviation, maybe 2 standard deviation, maybe this. Okay, this is what Chebyshev theorem says. This gives a very conservative estimate, of course, but still this gives us an idea. In an experiment based on the variance, we can find out what is the probability of getting a particular value within that range. So, one example will make it more clear. You see an example here. An electrical firm manufactures a 100-watt light bulb, okay, which according to specification written on the package has a mean life of 900 hours and a standard deviation of 50 hours. So, this electrical bulb, so it has a, suppose I am using a simple distribution, suppose it is this type of distribution. Till now I have not explained the type of continuous probability distribution or discrete probability. So, let us assume a normal distribution. So, this is what is given, mean is 900 hours. So, this is maybe the mean. Okay. So, mean means 900 hours, this side it will be greater than 900, this side it will be lesser than 900. Okay. And standard deviation of 50, maybe it's 50 is this point, that means it is 950 and this is 850 here. That, okay, that is the standard deviation is 50. So, if I am considering 1 standard deviation may be 950 at this point, this is 850, 1 standard deviation. 2 standard deviation, this side it is 1000, this side is 800 within 2 standard deviation. So, now what is the question? At most what percentage of the bulb fail to last even 700 hours? Fail to last even, so it is 900, maybe this much is 700. So, the question is what percentage of the bulb fail to last even 700 hours? So, that means my bulb, the value that I got, that means that my working life of the bulb is all in this range, lesser than 700. It is not in this range, greater than 700 is in this range. So, what I will do is that I will try to find out the probability within range from this 700, this side 700 means it is from 900 to 700, how many standard deviations? It is, if it is 50, it is 4. So, here, so 1100. So, what is the probability of finding in this range? I will find out using Chebyshev theorem, and then I will subtract it from that. 1 minus, I will get this area, isn't it? So, see here my 900 is mu is 900, sigma is 50. So, mu minus k sigma is 700. So, definitely k is equals to 4. That all without solving also we can say, because it is sigma is 50 is very easier to tell. So, now using Chebyshev theorem, what do we get? Probability of this is at least this value, that means greater than equals to 1 minus this. The probability that it will lie in the range of 700 to 1100, it is this much, 0.9375. So, what is the probability that it will lie, that it will be lesser than 700? This is 900. So, this is 700. This corresponds to 700. This corresponds to 1100. So, the probability that it will lie in this range is just 0.9375. Now I am interested in finding out this probability. So 1 minus of this probability, I will be getting this and this together. So it will be less than this, that will be divided by 2. So it is this much. Okay. You can just do it, and 1 minus of this, and it will then divided by 2, because it is this lesser than this as well as greater than 1100. It caters to both the portion, because we have just found out the probability of the middle portion, and we want to find out what is the probability that has appeared in the lesser than 700, right. So then what we got, 1 minus of this, it will cater to both the portion, lesser than 700 as well as greater than 1100. 1 minus of that value 0.9375 will give that, and we are interested on only lesser than 700. So whatever value we will get, probably that will be divided by 2, then we will get 0.03125. Fine. So I conclude here. So in this lecture, rather I should not say in this lecture and the previous lecture, that was lecture 7, but we learned about the basic theory of probability distributions. Earlier we have learned probability. Now in this last 2 lectures we have learned what is the probability distribution, what is a random variable. Then we have now learned what is a continuous probability distribution, discrete probability distribution. We have learned how to find out the mean of a distribution, variance of a distribution, and also we have discussed Chebyshev theorem. Like last time, again I am repeating, solve as many problems as possible. Okay. Now in my next lecture we will learn different discrete probability distributions. With that, I end this class. Thank you. Here the reference of the different books. Okay. Thank you guys.